this, and
it'll be solving quadratic. It's the worksheet, yeah. Worksheet. It's right by the purple text.
Purple did it. Okay, here we go. All right, we got through number 12. Let's try to get through some of these equations. Let me sketch it here. Okay. So this equation here, what's the first step I'm going to do? Here, I'm going to go over here on the right, and I'm going to start it. And then I'm just going to write it out like I would on a piece of paper. What's the first step I do with that?
You subtract the...
Well, yeah. Notice, first of all, that we have a quadratic that has a x squared term, has an x term, and it has a number. Whenever you see that, then you want to get everything on one side and 0 on the other.
Okay.
Okay? So in order to do that, here I've got to subtract 21. So now I end up with with me? Now I got to factor that. In other words, I want to take this quadratic and I want to turn it into two linear factors. So how do I factor that? The process. You and I haven't done much factoring.
No.
Well, have they taught you a method called the diamond method or the California method or anything like that?
No, I don't think so.
All right, then I'm going to show you how to do it the way I would do it.
Okay.
Okay. Step 1, break up your x squareds. How am I going to break that up? In other words, it's not going to be x times x. That is not equal to x squared. What is? One's got to be 2. Now, understand what you're doing when you're factoring. You are doing FOIL in reverse. You remember FOIL? Did they teach you FOIL?
I think so.
Okay. Well, FOIL is where if I had two linear factors and I was multiplying them together, I would multiply the first terms, then I would multiply the outside terms, then I would multiply the inside terms, and then I would multiply the last terms. So that's what we want here. The second step of factoring is to determine both signs. Based on this negative sign right there, what must both signs be?
They must both be negative?
No, if they were both negative, that would be a plus 21.
Oh. Then positive.
Nope, they're both positive, that would be a plus 21. What do they have to be?
I'm not sure.
They have to be opposite one another. In other words, one has to be positive, one has to be negative. So I can write it like this, but it might be the other way around. It might be one has to be negative and the other has to be positive. So I'm going to write it like that. Okay. Now, the next step is to deal with factors of 21. Give me the factors of 21. There's two of them right there over on the far left.
7 and 3. And then isn't that it?
That is it. So I got 4 choices. I can do 1. Here, let me point with my cursor. I can put a 1 there and a 21 there. I can put the opposite, 21 there and 1 there. Or I can put a 3 there and a 7 there. Or I can put a 7 there and a 3 there. Which one should we try first? First of all, we have to choose a set of factors. We're going to choose that set or that set.
Let's do 3 and 7.
Good. So now it's just trial and error. Okay. I could do 3 and 7, but that doesn't produce the correct middle term. Notice what middle term that produces. Plus 3x for the inside, minus 14x for the outside. Very important you understand what I'm talking about here. That's not the middle term. The middle term is minus x.
Yeah.
So I know 2 things. I know this is not the right answer. And I also know that if I move the 3 down to the negative sign and the 7 down to the plus sign, all I do is change the sign on this 11x. Instead of minus 11x, it becomes plus 11x. So I eliminate 2 possible answers by trying 3 and 14 or 3 and 7. Well, another way to try it. How about if we put the 7 there and the 3 there? Now let's do the inside and the outside. Let's see what we get. What's the inside produce?
The inside produces 7x. Positive 7x.
Outside?
Outside produces negative 3x.
Actually, it's negative 3 times 2, so it's negative 6x.
Oh, yeah. Okay.
Okay, that gives me plus x. We're getting closer to the right answer, but it's still not the right answer. What do I have to do?
Flip the sign.
Well, I got to move the sign down to there and move the 3 down to there. And that is automatically going to make it minus 7x plus 6x minus x. That is our middle term. Therefore, we have factored it properly.
Okay.
Okay. Now, I can't remember too many students where the first factoring problem I worked with them was a hard one like this. This is what I would call a second-degree factoring problem because it's got a coefficient in front of the x squared. However, let's finish this problem up. We're not quite done. Solve the equation. Well, I got this quadratic down to 2 linear factors. That's a linear factor times that linear factor equals 0. So what's my next step?
Just to solve it?
Doing what? By doing what? You have to recognize one very important factor of algebra.
I don't know.
When you have 2 things multiplied together and they're equal to 0, one of them has to be 0.
Oh, okay.
You can't find 2 numbers that are multiplied together that are equal to 0. They don't exist. Unless one of them is 0. That's the only way you can produce 0. So the way to solve this is I'm going to set that equal to 0. And that gives me x equals 7/2. You see how I get that?
Uh-huh.
And I'm going to set the second thing equal to 0, which gives me x equal -3. So those are my two solutions right there. X equal -3, x equals 7/2. If you plug either one of those into that equation, it will remain an equation.
Mm-hmm. So then we just solve it with those.
I've solved it. In other words, that's all you have to do to solve it. Is come up with both solutions. Now,
Okay.
let's go to the next one, because quite frankly, that one should have been last, maybe. Let's see what this one. This one is far easier. Notice what's missing.
It's just 0. It equals 0 already.
Well, what's missing is the x term. You have an x squared term, you have another number, but you don't have an x term.
Mm-hmm.
So we don't necessarily have to factor this like we did the first one. The first one had an x squared term, had an x term, and it had a number. This one has the x squared term and the number, but that's it. So this one, we have another way to solve it. Let's put the number on the right side. So we have x squared equals 81. Okay, now what's x equal to?
9?
Almost. Plus or minus 9?
Plus.
Both.
Oh.
Notice that x equal -9 is a solution. -9 squared is equal to plus 81.
Mm-hmm.
X equal +9 is a solution. 9 squared equals 81. So both of these are solutions. What you really have to remember is that whenever you are solving an equation, by taking the square root of both sides, always begin your answer with the words plus or minus.
Okay.
That's what I did. In other words, I went up to that and I took the square root of both sides.
Mm-hmm.
But that gives you a plus or minus solution 100% of the time. And I'll be honest with you, most students forget the plus minus. They just do. So they would say x equal 9. I will guarantee you one thing, you will lose points on your test if you put that. X equal 9.
Okay.
Okay, so you have to have the plus or minus 9. Now, let's go back and look at this problem. There's actually a second way to do it where you can't make a mistake. So I kind of like those ways where you can't make a mistake. When you are factoring, here's the priority that you factor. You know what GCF means?
Greatest common factor.
Good. About this is the second thing you look for. Dopes. What is that?
I don't know.
Difference of perfect squares.
Okay.
Notice that that is a perfect square, and that is a perfect square, meaning 81 is 9 squared, x squared is x squared. Okay?
Mm-hmm.
So we have a perfect square, we have another perfect square, and they're being subtracted. That is the difference of perfect squares. Well, that always factors into x minus 9, square root of both terms, times the conjugate, x plus 9, square root of both terms. Okay, you with me?
Yep.
So that would give you two solutions, x equal 9, x equal minus 9. So there's our plus and minus 9 that we got the first time, but I didn't have to remember to do anything. I just had to do it by difference of perfect squares instead of taking the square root.
Mm-hmm.
So those are both valid techniques. They both work, and they're going to ask you how to do both of them. This is actually probably the better one to use because you can't make a mistake. If you recognize that as difference of perfect squares, here, before we go on, let me give you another one. What's that factoring?
5.
So what times what?
5 times 5.
No, it's x minus 5 times
Oh,
x plus 5.
plus 5.
If you were to multiply these two together, you would get this.
Uh-huh.
So difference of perfect squares is exactly what it says. Again, that's a perfect square, that's a perfect square, and they are being subtracted. So if I have a squared minus b squared, that's difference of perfect squares, always factors into a minus b times a plus b.
Mm-hmm.
And now, if that's all equal to 0, then a is equal to b, or a is equal to minus b.
Yeah.
Okay? All right, so that's difference of perfect squares, which we can use there, or we can do that by taking the square root of both sides. Now, this one over here, I really can only do that by factoring, because it's got that x term in there. There's no way this is ever going to be difference of perfect squares. There's no way it's ever going to be greatest common factor. So this requires you to factor it like a quadratic. And by that I mean that times that.
Okay.
Okay? So let's go on. They're not getting any easier. Okay? So over here, first of all, recognize what you're looking at. What am I looking at?
You have x on both sides. You have an x squared and then a normal x.
Okay. And a number. There's a number right there.
Yeah, 41.
So it looks like we have a normal quadratic factoring. So what I want to do is I want to end up with something that looks like this. ax squared plus bx plus c equals 0. In other words, if I can get everything on one side and 0 on the other, then I'm in shape to do the problem. I can then do it by factoring.
Mm-hmm.
Okay. Well, they didn't particularly make this easy. What's the first thing I need to do?
You need to find the factors of 41.
No, not really. What I need to do is I need to put it in that format I just wrote. I need it to be 8x squared plus bx plus c. Well, how do I do that? What's the first step in getting this to this format?
Probably. Well, we have to get the stuff from the right side onto the left side.
Correct. Think PEMDAS. Remember PEMDAS?
Uh-huh.
Well, what does that stand for?
Parentheses.
Exponents. Got to do that part first. Parentheses and exponents. Let's get rid of that parentheses and exponents that I have over there.
Uh-huh.
So, first of all, I just got to square x minus 3. In other words, I'm not going to do anything to the left side. I'm just going to do something to the right side. Well, what happens when you square that? What do you get?
Is it negative 3x?
Now, here's what I'm going to do. X minus 3 times x minus 3. That's what x minus 3 squared means. FOIL that. What do you get?
So F stands for factor, right?
No, FOIL it. F stands for first.
Okay.
First means that term times that term.
So x squared.
Okay, and then the O stands for the outside terms.
Which would be negative 3x.
And the I stands for the inside terms.
Negative 3x again.
And the number, or the L, stands for the last two terms. Minus
9 plus 9.
Okay. So that's what goes on the right side. So these two usually get combined, almost always. So I have x squared minus 6x plus 9 on the right. Okay, in other words, all I did was square that right there. Now, what?
Well, I see you have 6x on both sides.
Okay, so I can cross those off. What else?
I mean, you have x squared on both sides.
Cross those off. So now I have an answer that looks very strange. 41 equals 9. Is it possible?
No.
It means no solution to that equation. Because I ended up with one number equaling a different number, you can never have that. So I cannot find a value of x that satisfies equation 15. Does not exist.
Okay.
Okay. Now, like I said, that's not usually the third factoring problem I go over with students. Usually factoring is almost like a 2-hour session because there are so many parts of factoring, and because factoring is something you have to know how to do. There's no getting around it. You're not getting through algebra without knowing how to factor. It's one of those things. It's like getting through arithmetic without knowing how to add and subtract. So we've got to learn how to factor. Okay, so let's give 16 a shot. Again, I'm not particularly pleased that they don't give us any easy problems here. But what's the first step I'm going to do on 16? Notice I've got an x squared, I got an x, and I got a number. Whenever you have all of those, what are you supposed to do?
Isn't it the ab squared plus bx equals, or plus c equals 0?
Good. ax squared plus bx plus c equals 0. This is the important part right there. You got to get 0 on one side. In other words, whenever you have both an x squared, an x, and a number, all three of those, got to get 0 on one side. So how do I get 0 on one side on number 16?
Well, you can subtract 2x squared from 8x squared, right?
Step 1. I still have 13 x's. And I want to move that
And
one
I
up.
would add 1 to 4, or subtract 1 from both sides.
Now I have my magic 0 on one side. So this is no longer the problem, this is. Okay. Now, I'm going to assume that this is a factoring problem. Only because of where it is. It's in this section right there. Not necessarily a factoring problem. When I look at it, I don't necessarily see a factoring problem. But I'm going to assume it is. If it is not factorable, then I'm going to have to use the quadratic equation on it. But given which section it's in, I'm going to say it's factorable. So what's the first step? I got to split up the x squareds. How am I going to do it?
2x on right there, yeah, and then x on the other one.
Now hold on. If I write x there, do I get 6x squared as my first term?
Oh no, you have to put 3 or yeah.
Now do I get 6x squared?
Oh no, you don't.
Yes, I do. 2x times 3x is.
Oh, you do. Yes. Okay.
So my job is to split up the 6x squared so that this term times this term equals 6x squared. Now, it doesn't have to be 2x and 3x. It actually could be 6x and 1x. But when you have a problem like this, it's a trial and error problem. In other words, you may have to try all possible combinations. And the first one you want to try is the one where the factors are closest together. 2 and 3 are closer together than 6 and 1.
Yeah.
Second step of factoring is what? Got the first step down. I've split up the first term properly.
Do we have to split up the second term?
No, not yet. What we have to do is the second step is figure out both signs. Both signs. In other words, the way we can figure it out is there's only one way to produce a -5. Remember, this comes from the last two terms being multiplied together.
So it's going to have to be a fraction, or?
It's going to have to be one sign is a positive, the other sign's a negative. So positive.
Just like last time, okay.
But it could be negative positive. I don't know which yet. You see why there's a difference. There's going to be a difference. The difference is because 2 is not the same number as 3. If you always start out with x times x, then plus minus is the same as minus plus. But when these two coefficients are different, then plus minus is not the same thing as minus plus. Now, the third step. Tell me factors of 5.
5 and 1.
That's it. So, I've only got 4 choices here. I can do 1 and 5. I can do 5 and 1. Or I can move the 1 down to the negative sign and make that a 1 and make that a 5, or opposite. So I have 4 choices. Okay, and I got to test each choice until I produce this middle term of 13. That's the way you do these. These are harder. There's more rules you got to do, and there's more trial and error that you have to do. But let's just randomly start out with 1 and 5. I don't know where to start. Let's try this. Okay? What does that produce as a middle term? Do your smiley faces, which is the inside and the outside.
So it would just be 3x then, right?
What's the outside?
The outside would be negative 10x.
Add those together. You don't get the right sign or the right number. Now, because I don't get the right number, there's no point in trying this option. Because when I try that option, I'm going to get the same number, the different sign. Notice that if I try this option, I get plus 7x.
Yeah.
So I've eliminated 2 options by trying that option. I've eliminated 1 and 5, and I've eliminated -1 and +5. So that's helpful. We only had 4 options. Now we got to try the other one. Instead of 1 and 5, let's try 5 and 1. That's a different option right there. What does that produce for the inside and the outside term?
15x and negative 2x.
Bingo. That produces my 13x. That's our answer. And that's the way you have to do these. These are trial and error. Meaning you just try all the possible factors of 5 until you get one that produces that middle term. So I know that that's true. In other words, I can take this quadratic, 6x squared plus 13x minus 5. I can break it up into 2 linear factors. Now what? Still haven't solved it.
We have to actually multiply the...
Oh, that would just be going back to that step.
Oh, okay.
If I multiplied it out, I'd be going backwards. Actually, it is the most important rule in algebra. It's called the fundamental property of algebra. When you have multiple things multiplied together and they are equal to 0,
it has to have 0.
One of them has to be 0. If I say x times y times z is equal to 0, one of those 3 numbers has to be 0. If I said 4 letters times each other is 0, one of them has to be 0. Well, when you're dealing with factoring, you're usually dealing with just 2 things. Okay? In my case, 2x plus 5 is one thing. 3x minus 1 is another. I'm saying that when they are multiplied together, they're equal to 0. So what's the next thing I can say?
That there's no solution.
No, I can say, well, either 2x plus 5 is equal to 0, which makes x equal minus 5 halves. You see where I get that? Or 3x minus 1 equals 0. In other words, what you do is you set both terms equal to 0 and solve. And if 3x minus 1 equals 0, x equals 1/3. There are your 2 solutions. And expect 2 solutions. When you're dealing with quadratics, you almost always get 2 solutions.
Okay.
Okay? All right, let's move on. Don't like the pace they're going at, but who am I to say? I got an x squared term. I don't have an x term. And I got a number. What's the best way to solve this?
Well, 84 isn't a perfect square, is it?
Nope.
So
I can still maybe simplify it. But what's the first step? What's x equal to?
the square root of 84.
Almost. How should you begin every sentence? With what words?
Positive or negative?
There you go. Because I'm taking the square root of both sides. When I take the square root of both sides in an equation, always begin your answer with the words plus or minus. Okay? So let's look at whether I can simplify that or not. If that is simplifiable, then I've got to be able to factor it into 2 numbers where one of them is a perfect square. Well, notice that that's divisible by 4. So that's 4 times 21. Which is 2 times root 21. You with me?
Yeah, and that's the answer.
Not quite. Because root 21, no, you're right, that is the answer. Root 21 could be divided into root 7 times root 3, but that's not really simplifying it. It's only called simplification if you can pull a whole number out of it. So root 21 is one of those numbers where it's not a prime number, but there's no factors of 21 where one of them is a perfect square. Remember how we did this section up here? We're always looking to factor, so one of the numbers is a perfect square number. We can't do it with 21, which means this is the final answer. So x equals, I still need my plus or minus, that didn't go away. So all I've done is simplified the radical 84.
Okay.
And all right, the next one. It's similar to 17. The only thing is it's got a -3 coefficient over here. Well, can I get it to this step? What do I got to do to get it to just w squared?
Multiply it by -3?
Not multiply it. What is it currently being? Currently, that -3 is a multiply. So you got to divide. Always do the opposite. And if I'm dividing that by -3, I got to divide that by -3. Okay, and that gives me w squared equals 71. Positive 71. It's not plus or minus yet because I haven't taken the square root of anything. All right. So if w squared equals 71, that's what that is 71. What's w equal to?
Plus minus square root of 71.
Perfect. One of the few students that gets it by the third time. Usually 2 weeks later, they're still leaving out the plus minus. And it's really, really important because I guarantee you'll lose half credit on the question if you leave out that plus minus. You absolutely have to have the plus or minus. Now, the only question is, can square root of 71 be reduced? Well, let's first ask the question, is 71 prime? Are there any factors of 71?
I don't think so. 71 and 1.
71 is prime. There are no two numbers that multiply together other than 71 and 1, which means that's our final answer. If I can't pull a whole number out of that thing, I can't even pull a factor out of it, let alone a whole number. There's our final answer. In other words, it's not 72. 72 would have been reducible. 72 is the square root of 9 times the square root of 8, which is 3 times square root of 4 times square root of 2. So that is 6 root 2. So just changing it by one number makes it reducible. That would be that.
But the final answer would still be w plus minus 71 squared, or square root of 71.
Correct. In our case, because it's 71 and not 72, then we can't do any of that. Or that. Or that. Because 71 is a prime number. When you find a prime number and you take the square root of it, just leave it alone. If it has no factors at all, then it's simplified. Even if it has factors, it could be simplified. Notice that the square root of 10 is what?
It's just, there's a school. That's a perfect square.
Well, that's the final answer. That is simplified. Because I could make it square root of 5 times square root of 2, but neither one of those is a perfect square.
Yeah.
So all I've done is turn two terms or one term into 2. Well, that's not simplification. So you don't ever do that. So my square root of 10 is the final answer. But notice square root of 8 is not. Square root of 8 can factor into one of them being a perfect square number. And now we have 2 root 2. So this is always done. This, you never do anything with it. So it's not just a question of whether you can factor it. It's a question of can you factor it where one of the factors is a perfect square number. That's always what you're doing. Okay?
Okay.
All right, let's keep going. Let me scroll down here so that I can get a little more of these problems in here. And let's see if we can do 1 or 2 of these at least before we run out of time. All right, we've done 17 and 18. Let's look at 19. Now, immediately this looks difficult because of a denominator. Where the heck did we get a denominator? We're not used to denominators. None of the other problems had any denominators. So that's the first thing I want to get rid of. How do I do it?
Do we multiply?
Well, actually, that's the second thing I want to get rid of. What's the first obvious step?
Minus 8 from both sides.
Okay. So now we have t squared over 20 equals 7. Now, how do I get rid of that denominator?
Can you multiply by 20 on both sides?
Perfect. T squared equals 140. Now, we have a standard looking quadratic, the same as that, same as that. In other words, I have a squared term, but I don't have a non-squared term. I don't have just a t. So how am I going to solve this?
T equals the square root of 140.
Almost.
Plus minus the square root of 140.
Okay. Now, that might be the right answer. It all depends on whether I can factor 140. So let's play with that a little bit. Are there any 2 factors of 140 where one of them is a perfect square number? In other words, clearly it's 70 times 2, but that doesn't work. Neither one.
There's 14 times 10, but neither of those are perfect squares.
What's that?
There's 14 times 10, but neither of those are perfect squares.
Exactly. So let's list our perfect square numbers. Over here on the left. Is this number divisible by any of them?
No.
Remember that a number is divisible by 4 if its last 2 digits are divisible by 4. Is 40 divisible by 4?
Yes. So it would be 35, right?
Perfect. Now, so what's that become?
It becomes 2 times the square root of 35.
Now, it's square root of 35. Is that factorable? Where one of them would be a perfect square.
I don't think so. There's 7 and 5.
That's it.
Yeah.
Neither of those is perfect square numbers, so that's our final answer. T equals what?
2 times the square root of 35.
Oh.
Oh, plus minus the square root of 35. 2 times the square root of 35.
Trust me, that is going to be one hard thing to remember. It just, I don't know why it is, but I know that if I've got 20 students, 15 of them are going to leave it off. And I emphasize it every single time I do a problem. I have them put the plus minus in there. I remind them that anytime they're solving an equation by taking the square root of both sides, they need to begin their answer with plus minus. So I don't know what else to do to get somebody to remember that. Maybe you have a way of remembering it that will work. You need to. Okay, you need a way of remembering to always do that.
Okay.
Okay? And it's important. It's as important as being able to solve the problem. You're going to lose half credit if you leave that plus minus off there.
Okay.
Okay? I'm leaving this list of perfect square numbers up. In fact, I'm
Okay.
adding to it a little bit. Okay, so let's do number 20. We got time for at least this one. So I got
Mm-hmm.
3n squared plus 5 equals 50. I have a squared term. I do not have a non-squared term.
So we could start off by subtracting 5 from 50, and then we could multiply 3 on both sides.
Hold on. That 3 is already a multiplier.
Ah, I see.
You
So
always
we
do
have
the opposite. When
we
you're
have to
trying to get rid
divide
of a
3 on
number,
both sides.
I want the final answer to be n. N
Yeah.
equals something. So
So
I've got to get rid of the 3 and I got to get rid of the squared. So I get rid of the 3 by doing the opposite of what that 3 is doing. That 3 is currently multiplying. So now I get n squared equals 15. And n is what?
Equal to the square root of 15. Oh, positive plus minus square root of 15.
See, I don't know how to get you to remember that. Most people end up doing it exactly the way you do it. They give me square root of 15 and then they remember they got to stick a plus minus in front of that. Now, does that simplify? Does square root of 15 simplify?
No.
No, it does not. It's square root of 5 times square root of 3, so I leave it as square root of 15. In other words, there's no perfect factor. And those are the only two that could possibly be it, right? 4 and 9. I mean, I obviously don't have to test 16. There's no way 15 is divisible by 16 or 25 or 36 or 49. So usually when you're trying to simplify these radicals, you're really trying just those first couple numbers.
Mm-hmm.
All right. Got time for one more? Let's do it. Let's do that one right there. Well, got a y squared, right?
Yeah.
Do I have
So
a
we should
y?
start off. Can we subtract 9 from both sides? That gives us negative 4y squared equals 48.
Okay.
And then we divide by negative 4 on both sides. And then y is equal to plus minus the square root of negative 12. And then that equals to the square root of 4, the plus minus the square root of 4 times the square root of 3. And so the final answer would be y equals 2 times the square root of 3.
Very good, except for one problem.
Okay.
And that is you can't take square roots of negative numbers.
Okay.
However, what do you get when you take the square root of a negative number? You get I, that imaginary number. So the square root of negative 12, the first thing I do is I pull out my imaginary number. So it's that, correct?
Mm-hmm.
So that would be I times square root of 12, which is the square root of 4 times the square root of 3. So that would be I times 2 times square root of 3. I put my I behind it always. So I write it like this. And my plus minus didn't go anywhere, so I still got my plus minus. So this is the answer. Y equals plus or minus 2 times the square root of 3 times I, and that I is not under that radical sign.
Okay.
So before I let you go, let's just deal with I again. Tell me what this is.
It's going to be
split it up and all. In other words, whenever you have the square root of a negative number, always make this the first thing you factor out.
Okay, so the square root of negative I times the square root of 25, which is gonna, you want to simplify that into the square root of, well, that's as simplified as it can get, huh? Because there's no perfect squares in 25.
Well, I got to turn that into I.
Okay.
And you always put the I after the coefficient, so that becomes 5I.
Okay.
In other words, that's 5. 5I would be the answer to that. Now notice that there's no plus or minus in front of that. Because I said to you, what is the square root of minus 25? That square root sign always implies the plus answer. If I gave you the problem like this, x squared equals minus 25. Now I got to take the square root of both sides, so I get x equals plus or minus the square root of minus 25. You with me? Which means x equals plus or minus 5I.
Okay.
So the only time you have to have that plus minus is when you have solved an equation by taking the square root of both sides. When I go from this step to that step. That's what I did, is I took the square root of the left side and I took the square root of the right side. But when I do that, I always have to add the plus minus. Yeah.
Okay.
Nathan, that's pretty good. Wow. That's a whole half semester of algebra right there. It is, because we covered virtually every kind of factoring except the easy kind. That was the only kind we didn't cover, was the easiest quadratics. We covered all the hard ones, all the problem ones, all the ones that require plus or minus, plus we covered imaginary numbers also.
Yeah, thank you.
You're welcome. I will talk to you next time, Nathan.
All right, bye-bye.
Bye-bye.